Hello, very good evening, students. Welcome to PW platform. Am I audible and visible? Satyam Binayak, Prashant Prabhakar, Get Easy, all clear? Start करें आज का session. Give me the clearance, please. All good, very good. चलिए. So welcome back. Very good evening again to all of you. Welcome to PW platform. Get crash course in the course of algorithms. और हमने अब तक देखा टाइम एंड स्पेस कॉम्प्लेक्सिटीज और फिर आगे भी देखे हम डिवाइड एंड कॉन्कर मेथोडोलॉजी पैराडाइम. आज हम स्टार्ट करेंगे ग्रीडी मेथड इन क्रैश कोड मोड्स और फास्ट रिवीजन मोड, जहाँ पर हम पैराडाइम देखेंगे ग्रीडी मेथड का, कैसे प्रॉब्लम सॉल्व की जाती है विद ग्रीडी अप्रोच, उसके कैरेक्टरिस्टिक क्या है, उसके ड्रॉबैक क्या है. और एज केस स्टडी वी विल टेक अप द प्रॉब्लम ऑफ लेट अस से few problems we'll take, like knapsack is the first one to begin with, और वैसे दूसरे अदर प्रॉब्लम्स भी है जैसे जॉब सीक्वेंसिंग विद डेडलाइंस है, मर्ज पैटर्न्स है, एक्सेट्रा. सो विल ट्राई आवर लेवल बेस्ट टू कवर अप विद गुड नंबर ऑफ प्रॉब्लम्स. तो एजेंडा हमारा होगा बेसिकली we'll understand first the ideology, general method या control abstraction बोलिए, then knapsack problem. फिर next session perhaps we'll also look into some graph based problems like single source, shortest path, Dijkstra's algorithm, etc. ठीक है. So first we'll begin our discussion now with the paradigm of understanding what is greedy strategy, greedy method. कुछ basic points लिख दूंगा मैं पहले so that you can have clarity of understanding. Greedy method is basically an algorithm design technique. Like divide and conquer, there is also an algorithm design technique essentially used for solving problems, whose solutions, मतलब जो problems आप solve कर रहे हो, whose solutions, जिसके solution, जो problems आप solve कर रहे हो उसके solutions, whose solutions are viewed as a result of making a sequence of decisions. यहाँ पर थोड़ी टर्मिनोलॉजी अंडरस्टैंड करना ज़रूरी है, तो पहले मैं थोड़ी टर्मिनोलॉजी डिफाइन करूँगा, फिर उसके बाद पैराडाइम देखेंगे हम, फिर टाइप्स ऑफ ग्रीडी अप्रोचेस देखेंगे, फिर केस स्टडीज. दैट विल बी द सीक्वेंस इन विच वी वुड बी मूविंग. इज अ डिजाइन टेक्निक यूज्ड फॉर सॉल्विंग प्रॉब्लम्स हुज सॉल्यूशंस आर सीन आर व्यूड एज अ रिजल्ट ऑफ मेकिंग ए सीक्वेंस और सेट ऑफ डिसीजंस. मतलब जो भी प्रॉब्लम के आपको जो सोल्यूशन डिटरमिन करना है और वो सोल्यूशंस होंगे making a set of decisions, right? Solution is viewed as a result of sequence of decisions. You can solve the problems using greedy approach. आप लिख के मुझे बताइए प्लीज कि कैसे those decisions, those set of sequence of decisions are made in greedy method. What is the basic approach of solving problem based on greedy method? Basic approach क्या है? Yes, choose greedily. Choose greedily का मतलब क्या है? Jaskaran Singh, can you elaborate on that? Choose greedily means what? How are you going to make the decision? That is very important to understand in greedy method. The paradigm is the decisions are made in a stepwise manner. This is important. Stepwise manner, step by step. Optimal substructure, not exactly. That is a property for dynamic programming most often. Jaskaran Singh. Optimal substructure. Stepwise manner, where at every step, या फिर बाद लोग इसको sequential manner भी बोलेंगे, step by step या sequential way. sequentially, where at every step apply local optimality, local optimality, जो आप बताए कि greedy approach. That means at every step, out of all the possible options available, greedily select that option which satisfies your objectivity, which satisfies your criteria. So any problem that needs to make a set of decisions, sequence of decisions, and these decisions are made in a stepwise manner, where at every step, हर स्टेप पर जितने भी आपके ऑप्शंस अवेलेबल हों, उन ऑप्शंस में से आप ग्रीडीली वो ऑप्शन को सेलेक्ट करेंगे जो आपका क्राइटेरिया सेटिस्फाई करेंगे. मतलब feasibility criteria होने दीजिए या objectivity होने दीजिए, whatever it is. That is the basic paradigm of greedy approach. Make a stepwise decisions where at every step, out of all the available options, greedily select that option which satisfies your constraints or criteria. So यहाँ पर to understand really the working principle or the working mechanism of this, I feel it is more appropriate for you to understand some terminology. ये टर्मिनोलॉजी की कैरेक्टरिस्टिक ये है जो मैं अब डिफाइन करने जा रहा हूं. ये टर्मिनोलॉजी की कैरेक्टरिस्टिक ये है कि दिस विल बी एप्लीकेबल नॉट ओनली टू ग्रीडी मेथड बट विल आल्सो बी एप्लीकेबल टू डायनामिक प्रोग्रामिंग, विल आल्सो बी एप्लीकेबल टू अदर स्ट्रैटेजीज लाइक बैक ट्रैकिंग एंड ब्रांच एंड बाउंड. तो इसलिए मैं चाह रहा हूं कि आप ये ईच एंड एवरी टर्म थरोली अंडरस्टैंड कीजिए. फर्स्ट वी विल से प्रॉब्लम डेफिनेशन. प्रॉब्लम डेफिनेशन, आप प्रॉब्लम डिफाइन करेंगे फॉर विच यू वांट द सॉल्यूशन फर्स्ट, राइट? यू डिफाइन द प्रॉब्लम. एवरी प्रॉब्लम विल हैव व्हाट आर कॉल्ड कंस्ट्रेंट्स. कंस्ट्रेंट्स का मतलब है कंडीशंस. हर प्रॉब्लम के अपने कंस्ट्रेंट्स होते हैं. अगर आप सॉफ्टवेयर इंजीनियरिंग टर्मिनोलॉजी से बात करेंगे तो आप बोलेंगे रिक्वायरमेंट्स, राइट? रिक्वायरमेंट्स जैसा ऑपरेटिंग सिस्टम में हम बोलते हैं कि कंस्ट्रेंट्स आर नथिंग बट द रिक्वायरमेंट्स ऑफ द क्रिटिकल सेक्शन प्रॉब्लम, फॉर एग्जाम्पल. So those are constraints. These constraints are of two types. जो constraints की हम बात कर रहे हैं, एक है implicit constraints और दूसरा है explicit constraints. Implicit and explicit. क्या कोई मुझे लिख के बताएगा what is implicit constraint? Come on, boys and girls. What is implicit constraints? Anybody? What do you understand by implicit constraint? Come on. Automatic. No. Implicit is not automatic. Implicit constraints are internal or local conditions of the problem. Local conditions. It is local to that problem. No other problem will have same implicit constraints. हर problem के अपने own implicit constraints होते हैं. To better understand this meaning of implicit and explicit constraint, I will take an example of a problem, a game playing problem called n-queens problem. आपको शायद पता हो this problem, n-queens problem. एक simple way में समझा दूं मैं what is n-queens problem. It's a game playing. We are given an n by n chessboard. Like for example, we take n is equal to 4. So that means we are given a 4 by 4 chessboard. Like this. And we are given 4 queens. Let us name the queens as q1 to q4. These 4 queens are to be placed on the chessboard. आपको ये 4 queens को chessboard पर place इस तरह करना है कि no 2 queens are attacking with each other. मतलब no 2 queens should be on the same row, no 2 queens should be on the same column, and no 2 queens should be on the same diagonal. These 3 conditions, that no 2 queens should be on the same row, same column or same diagonal, are what are called as implicit constraints of the problem. ये सिर्फ 4 queens problem या n queens problem के ही condition होंगे. No other problem will have these implicit constraints. So each problem will have its own implicit constraints that is local to the problem. ठीक है? Then explicit constraints generally define the boundary of the problem. Boundary. इट लिमिट द साइज ऑफ इनपुट और आउटपुट, जनरली आउटपुट्स। जैसा कि हम डिस्क्राइब करेंगे सोल्यूशन इन एन अरे एक्स वेयर ईच एलिमेंट x1 x2 x3 डिनोट द पोजीशन ऑफ द क्वीन। फर्स्ट क्वीन कहां पर प्लेस करोगे, सेकंड क्वीन कहां पर प्लेस करोगे, थर्ड क्वीन कहां पर प्लेस करोगे, each xi डिनोट द पोजीशन ऑफ क्वीन आई। So in terms of column number, like this column number 1, column number 2, column number 3, column number 4, so each xi lie between 1 and n। या तो आप यहां प्लेस करोगे, या यहां प्लेस करोगे, यहां प्लेस करोगे, यहां प्लेस करोगे। So this is also a constraint, this is limiting the value of x of I, that is called explicit constraint, boundary of the problem। Limiting the value of n is also explicit constraint। So each problem will have its own constraints, implicit and explicit। फिर थर्ड पैरामीटर जो आपको अंडरस्टैंड करनी है वो है सॉल्यूशन स्पेस। ईच प्रॉब्लम विल हैव इट्स ओन सॉल्यूशन स्पेस। जैसा कि अगर हम सॉल्यूशन स्पेस बात करें एन क्वींस की, तो वो होगा ऑल पॉसिबल वेज ऑफ प्लेसिंग द क्वींस ऑन द बोर्ड, ऑन द चेस बोर्ड, वेदर अटैकिंग और नॉन अटैकिंग, वेदर अटैकिंग और नॉन अटैकिंग। क्वींस चाहे अटैकिंग मोड में हो या नॉन अटैकिंग मोड में हो, all possible ways of placing the queens on the chessboard, whether attacking or non-attacking, that defines solutions। So जैसा कि for example, size of solution space for n queens problem will become n factorial, will become n factorial। ठीक है, so that is called solution space। So हर remember please, हर problem का अपना own solution space होता है। Generally मैं ये कहता हूँ students को कि in the GATE exam this could be a potential 1 mark question, this could be a potential 1 mark question। कोई भी प्रॉब्लम आपको दिया जाएगा, उसका सोल्यूशन स्पेस एज ए मैटर ऑफ फैक्ट कैन बी आस्क्ड एज ए मल्टीपल चॉइस क्वेश्चन, एमसीक्यू क्वेश्चन। जैसा सोल्यूशन स्पेस फॉर n क्वींस प्रॉब्लम इज n फैक्टोरियल, कोई और प्रॉब्लम का सोल्यूशन स्पेस होगा 2 पावर n, कोई और प्रॉब्लम का होगा n स्क्वायर, कोई और प्रॉब्लम का होगा इनफाइनाइट, इनफाइनाइट भी हो सकता है सोल्यूशन स्पेस। तो डिटर्मिनिंग द सोल्यूशन स्पेस ऑफ ए प्रॉब्लम प्राइमरली इज ऑल्सो एन इक्वली इंपॉर्टेंट एस्पेक्ट। All possible ways of placing the queens on the chessboard, all possible ways of organizing the inputs, अगर आप general way में पूछे, all possible ways of organizing the inputs, right? Whether attack, I mean satisfying, whether satisfying or implicit constraint or not is not a constraint, but should satisfy only explicit constraint. All possible ways of organizing the input satisfying explicit constraint define what is called solution space. That is called solution space. ठीक है? Every problem will have solution space. उन solution space में you look for only those solutions which satisfy implicit constraint। क्या मुझे आप लिख के बताओगे कि what do you call such solutions in the solution space that satisfy implicit constraints of the problem? Come on, what do you call such solutions in the solution space that satisfy implicit constraints of the problem? आप क्या बोलेंगे उसे? They are known in the literature by what term? Come on, boys and girls. No, Satyam Binayak, that is not optimal. That is called feasible solutions. That is called feasible solutions. Feasible solution. The feasible solutions are those solutions that satisfy implicit constraints. Implicit constraints. Like for example, अगर आप n क्वींस की बात करेंगे 4 क्वींस प्रॉब्लम में, क्या एक feasible solution बताओगे आप मुझे for 4 queens problem? Can you write one feasible solution in terms of column numbers 1, 2, 3 for queen 1, queen 2, queen 3, queen 4, x1, x2, x3, x4? What should be the values for a feasible solution? Tell one feasible solution for 4 queens problem. Come on. Feasible का मतलब correct solution, right? So that's why this implicit constraint is also sometime in the literature is known as feasibility criteria. Feasibility criteria is also called in the literature as feasibility criteria. So tell me one solution, 2, 4, 1, 3. Correct. That is correct. See on board. I can have a queen placed here, 2, 4, 1, 3. This is called feasible solution. And 3, 1, 4, 2. That is also possible. 3, 1, 4, 2 is also possible. From this end, 3, 1, 4, 2. So n queens problem has 2 feasible solutions. 4 queens problem has 2 feasible solutions. 4 queens problem has 2 feasible solutions. इसका मतलब ये है कि ए प्रॉब्लम में हैव मल्टीपल फीजिबल सॉल्यूशंस. ये भी बात आप याद रखिए, प्रॉब्लम में हैव मल्टीपल फीजिबल सॉल्यूशंस. प्रॉब्लम में हैव मल्टीपल फीजिबल सॉल्यूशंस. ठीक है. इट में हैव जीरो फीजिबल सॉल्यूशंस आल्सो. क्यों? अगर मान लीजिए यू आर टेकिंग ए 3x3 क्वींस प्रॉब्लम. प्लीज ऑब्जर्व 3 क्वींस, 3x3 chess board. It will have 0 feasible solutions. You cannot have a feasible solution here. Check it. 2 queens problem have 0 feasible solutions. The problem may have more than one feasible solution. Problem may have, instance of a problem may have 0 feasible solutions also. So that is called feasible solution. ठीक है. Next is, few problems will have what is called objective function. Objective. Few problem will have something called objective function. What may be objective function? Objective function refers to, let me write it here, refers to minimization or maximization of a given criterion in the problem, of a given criteria. बहुत important है, people generally get confused. Given criterion. Objectivity always refers to minimization or maximization of some given criteria of the problem. Like for example, एक एग्जाम्पल अगर हम लेंगे, shortest path problem, shortest path problem in a graph. So you are given a graph and then you want to find the shortest path in between the two vertices, say S and D, source and destination. There may be many paths connecting S and D, many paths connecting S and D. You want to find that path which is having the least cost. तो यहाँ पर आपका मतलब है, you want to minimize something or maximize something, right? You want to minimize or maximize. Like here, shortest path हम जब बोल रहे हैं, so you want to minimize it. So minimizing the cost of the path. So cost is the criteria which you want to minimize. That is called objective function. So dear students, यहाँ पर ये बताना चाह रहा हूँ कि problems may have objective function. Some problems, few problems may have objective function. So problems which have objective function, right, means there will be some criterion given which you would like to minimize or maximize, right? So that is objective function. अब यहाँ पर एक बताइए आप, what is the objective function in N-Queen's problem? Let me see how many of you can understand and tell me. What is objective function in N-Queen's problem? Can anybody tell? Can anybody tell me what is the objective function of N-Queen's problem? Is there any criteria which you would like to minimize or maximize in the N-Queen's problem? Come on. It's an interesting aspect. Based on this, I am going to make a definition of a classification of problem. Is there any criteria in N-Queen's problem which you would like to minimize or maximize in N-Queen's problem? Yes, very correct, Satyam B. Naik. N-Queen's problem has no objective function. Please remember. No objective function. There is nothing like which you would like to minimize or maximize in N-Queen's problem. कोई अब ऐसा criteria नहीं है जो आप minimize या maximize करना चाहोगे N-Queen's problem में. मतलब यह है कि हर problem में objective function होना जरूरी नहीं है. जैसा कि searching problem भी आप ले लीजिए, there is no objective function in searching problem. Sorting problem, there is no objective, right? अगर आपने पढ़ा हो sum of subsets, there is no objective function. उसी तरह N-Queen's problem also does not have objective function. तो मतलब जो भी प्रॉब्लम्स में अगर ऑब्जेक्टिव फंक्शन होगा तभी हम एक नेक्स्ट सोल्यूशन, यहां पे मैं थोड़ा स्क्वीज कर लूंगा इसे, तो प्लीज अंडरस्टैंड. So if a problem has objective function, if any problem has objective function, then you have to find what is called optimal solution. Optimal solution. What is the definition of optimal solution? Optimal solution is that feasible solution, that satisfies objective function. That satisfies objective function. Is that feasible solution which satisfies objective function? There's a shortest path में कई paths है, but that which is satisfying your objectivity, that is called optimal solution. Please remember, optimal solution always refers to value. and there can be only one minimum or one maximum value. That is why we say optimal solution is always unique. सिर्फ एक ही ऑप्टिमल सॉल्यूशन होगा आपके पास, क्योंकि आपके पास सिर्फ एक ही मिनिमम वैल्यू होगी या एक ही मैक्सिमम वैल्यू होगी. I cannot have two minimum or two maximum for a given problem. So therefore, my dear boys and girls, please remember optimal solution is always unique. Feasible solution need not be unique. Feasible solution need not be unique. So based on this paradigm of feasibility and optimality, please, a very important point, I don't know whether you learned it earlier or not. Based on this paradigm of optimality and feasibility, we classify problems, any problem, into two types. Come on, write down and tell me, based on feasibility and optimality, we classify problems that we are going to solve. We classify the problems into two types. लिख के बताइए what are the two types. Let me see how many of you are knowledgeable. देखेंगे कितने लोगों को पता है. We classify the problems into two types based on this aspect of feasibility and optimality. मतलब अगर, yes, very good. Come on, others also. We classify the problems as what? We classify the problems into two types. One is called decision problem and the other is called optimization problem. Decision or optimization. If a problem has objective function, means we find optimal solution. So such problems are called optimization problems. Correct. And if a problem doesn't have this the objective function, right? You need to find only feasibility criteria. That's it. You need to fulfill only feasibility criteria. Means their result, for example, is generally yes or no. That's why the term decision, yes or no, or 0 or 1, true or false. Such problems are called decision problems. क्या आप queen place कर सकते हो या ना कर सकते हो? That's it. For 3 queens you say, so no sir, we cannot place. For 3 queens. For 4 queens, yes sir, we can place in 2 ways. For 8 queens, you can place in 92 ways. Feasibility. Searching problem is a decision problem. Why? Given an array with n elements, I want to search for element x. I want to know whether x is existing or not. Result is what? Result is yes sir, it is existing. Or you say no sir, it is not existing. Yes or no. Such problems are called decision problems. So therefore, greedy method, dynamic programming. Remember please, I am telling in a very general way, greedy method, dynamic programming, backtracking, branch and bound. These are the strategies which are used for solving problems which belong to both categories. Sometimes decision, sometimes optimization. So that is the total terminology, the basic background behind understanding of the working principle of greedy method. Right? So the terms are what? Check it again. Problem definition is given. Every problem will have what are called constraints. Constraints are of two types, implicit and explicit. Implicit constraints are the local conditions of the problem, right? Every problem will have its own implicit constraints. Explicit constraints generally limit the size of the problem, boundary of the input or output. Then solution space, very important. Every problem I am saying will have its solution space. All possible ways of organizing the inputs satisfying only explicit constraint, not implicit, is solution space. Solution space generally is expressed as a mathematical function, Then in the solution space, listen here, now I am telling you, in the solution space, greedy method will have its own approach of searching the solution space. Dynamic programming has its own approach of searching. Backtracking has its own approach, and then branch and bound has its own approach of searching the solution space. और थोड़ा आगे बढ़ के आपको ये बता दूं, the concept of solution space in backtracking and branch and bound generally is called state space tree. वहाँ पे थोड़ा अलग terminology होगी, state space tree. Solution space भी बोल सकते हो आप, state space tree भी बोल सकते हो, but generally the word state space tree is used in backtracking and branch and bound. Solution space is used in greedy method and dynamic programming. चलिए, solution space. So remember, solution space is always expressed as a mathematical function, a function of input size, mathematical function. वो होगा infinite होगा या n factorial होगा या 2 power n होगा या n square होगा, something like that, some mathematical function. हम देखेंगे जब problem solving करेंगे. Feasible solutions are those solutions that satisfy implicit constraints of the problem. Problem may have more than one feasible solution, या depending on the instance zero feasible solution भी हो सकते हैं. फिर उसके बाद objective function problem. Some problem, few problem may have objectivity, which is nothing but to minimize or maximize a given criterion. ठीक है? That is objectivity. In case if a problem has objective function, then compulsorily you have to find optimal solution. अगर ना हो तो such problems are called optimization problems. अगर objectivity ना हो तो सिर्फ आप feasibility criteria satisfy करोगे और decision determine करोगे कि is it true or given, I mean for a given instance is it true or false or 0 or 1. So such problems are called decision problems which do not have objectivity, and those which have objectivity they are called optimization problems. ये बहुत important background है, इसीलिए मैंने पहले ये discuss किया, because this will be useful for dynamic programming paradigm also, the related terminology, right? So the working paradigm of greedy method is that greedy method, as I said, just एक timeline के हिसाब से आपको बता दूंगा, basically makes stepwise decisions in the solution space, stepwise. Step 1, it see what options are available. Among the options available, it will greedily select that. That's why the term greedy, right? Stepwise decisions, where at every step, out of available options, greedily select. That's why the term greedy. Greedily select that option that satisfies, which satisfies the objectivity and feasibility, whichever is applicable. या दोनों भी अगर है तो दोनों भी applicable. So this principle of making a stepwise manner, making the decision in a stepwise manner is generally called local optimality. The principle of local optimality. And most of the time for greedy method we solve problem based on what we call optimization problems. ठीक है? तो चलिए आगे बढ़ के देखेंगे. Some theory is there, and then control abstraction भी मैं आपको बता दूंगा. And based on the control abstraction, you can basically understand the working principle very well. और वो control abstraction के basis पर हम I mean इसकी time complexity की भी बात करेंगे. What is the minimum time complexity of any problem solvable by greedy method? देखिए आप, greedy method is the most straightforward design technique which can be applied to a variety of problems. The algorithm works in steps. So I'm underlining the important part. Works in steps. In each step it selects the best available option greedily until all the options are over. Most of the problems have n inputs and require us to obtain a subset that satisfies some constraints. Any subset, listen that, any subset that satisfies these constraints, implicit constraints, is called feasible solution. A feasible solution that either minimizes or maximizes a given objective function is called as optimal solution. So पूरे related terminology एक जगह मैं लिख दिया हूँ, procedure भी लिख दिया हूँ, so that when you get these slides, this will be very useful for you as a short note at one place. ठीक है? The greedy method suggests that one can devise an algorithm that works in stages, step by step, considering one input at a time. Look at this. At each stage, a decision is made regarding whether a particular input is in optimal solution or not. This is done by considering the inputs in an order determined by some selection procedure, right? If the inclusion of the next input into the partially constructed optimal solution results in, यहाँ पर in डालना चाहिए, results in suboptimal or infeasible solution. देखिए अगर कोई input से suboptimality हो रही है या फिर infeasibility अगर हो रही है at any stage by including a particular input. Look at again, if the inclusion of the next input into the partially constructed solution results in suboptimality or infeasibility, then that input is not considered, it is rather rejected. Right? Otherwise it is added, and this selection procedure itself is based on some optimization measures which will vary from one problem to another problem. This is the approach of greedy method. Before I start working, I would appreciate, please have a look at it on your own, right? On your own, make a study of it, and then you tell me what will be the time complexity of any problem solvable by greedy method with this control abstraction. Come on, boys and girls, please have a look at it carefully. This is called the control abstract procedure. मतलब इस procedure से हम generally problem solve करते हैं, any problem to be solved with greedy method. Step by step you read and see what is happening, what are the abstract procedures used here, what are their functionality, और उसके basis पर मैं essentially आपसे ये पूछ रहा हूँ, based on this procedure, my question to you is this: the time, the minimum possible time, the minimum time to solve a problem using greedy approach is dash. This is very interesting conclusion. Polynomial time, okay, but I want what kind of function? Polynomial function. Okay, देखिए आप, I'm solving some problem. Let us call the problem as P. I'm solving some problem, please. We'll call it as some problem P, whose input is in an array, or maybe you can say A is a list, some data structure A. You can say the size of that input is n. The size of that input is n. It may be a list, it may be some file, it may be a linear array, right? It could be something, some data structure of size n. Okay. A1 to n contain the n input, that's what I told just now. Here it is assuming like an array, no problem. First step, solution is initialized to 5. That solution may be either feasible solution or optimal solution. It depends on the problem, जैसे मैंने आपको पहले कहा. The solution is initialized to 5. The second step, for I is equal to 1 to n, these are the steps. I am using an abstract procedure called select from the array A, from the input A. That means at step 1, I am seeing what options are available with respect to my inputs at that step, and I am making a selection through an abstract procedure. तो मतलब ये जो select का यहाँ पे देखिए आप, select के बारे में लिखा हूँ, selects an input from array and removes it. The selected input's value is assigned to x. So now I am deciding whether x can be part of my solution or not, right? So I have selected that. So after selecting, I am checking through another abstract procedure by name feasible. So what feasible is doing? Feasible is a Boolean valued function. मतलब feasible will return either true or false. Boolean valued function that determines whether x can be included into the solution vector or not. Feasible is a solution, is a abstract procedure which is going to return either true or false. Is it feasible to include x into my already constructed solution so far? क्या वो feasible है? क्या हम add कर सकते हैं x को या ना कर सकते हैं? It will return true or false. It depends on, it varies from problem to problem. चलिए. So if it is feasible, अगर वो return true कर रहा है तो हम क्या कर रहे हैं? How we are adding union x into solution. We are adding x into solution. So union is another function that combines x with the solution and update the objective function. Objective function को update कर देगा वो. अगर वो feasible ना हो, listen, boys and girls, if it is not feasible, this condition is not there, is false, then we don't add it, but rather we go and repeat. We go for next step. We go for next possibility, next possible solution, next possible solution to be considered in the next iteration. So we repeat this for n times maximum, and then finally, जब हमारे when we finish off making decisions on all stages, stage 1, stage 2, stage 3, stage 4, then I simply return my constructed solution. That's it. This is the approach, general method for solving problem based on greedy method. अब यहाँ पर मैं पूछ रहा हूँ, based on this understanding of greedy method, जो procedure हम यहाँ पर outline किए हैं, based on this understanding, can you please tell me what is the minimum time complexity to solve a problem using this greedy approach, जो मैंने यहाँ पर लिखा. So please tell me exactly what will be the minimum time. वो time उससे less हो ही नहीं सकता. What is that? Very simple. What is the time complexity of this? Invariably, I'm asking you, what may be the minimum time possible complexity of this control abstract procedure of greedy method? Very simple. I don't know why you are taking so much time. Minimum time. Very good, Naveen Kumar. Naveen Kumar passed on order of n. Absolutely correct, order of n. The minimum possible time complexity of any problem solvable by greedy method with this control abstract procedure, remember, is order of n. What is n? Input size. अब यहां पर एक इंटरेस्टिंग, यस, नाउ पीपल स्टार्टेड रिस्पॉन्डिंग, वेरी करेक्ट. तो अब यहां पर बताइए, ये बहुत इंपॉर्टेंट है प्लीज, ये बहुत इंपॉर्टेंट है कि व्हेन विल इट बी ऑर्डर ऑफ एन. ये बहुत इंपॉर्टेंट है. लेट मी सी हाउ मेनी ऑफ यू कैन टेल व्हेन विल इट बी ऑर्डर ऑफ एन. कम ऑन, व्हेन विल इट बी ऑर्डर ऑफ एन? व्हेन देखेंगे, हाउ विल रिस्पॉन्ड. व्हेन, अंडर व्हाट सर्कमस्टांसेस विल इट बी ऑर्डर ऑफ एन? Come on, boys and girls, that is interesting to analyze. When will it be order of n with this procedure? That is very important. Yes, very correct, Satyam B. Naik. When all, no. Shifu Khadir, it is not correct. When we will have the feasible solution. No, it is not like that. Under what case, under what conditions, under what assumptions that the time complexity will be order of n? Somebody has written earlier, like I read the comment, abstract functions is order of n. What are abstract procedures? See, the abstract procedures are select, feasible and union. If these abstract procedures take a time, select, right, and then we have feasible and union. If these control abstract procedures are individually orders of one, is it not? Don't you agree that the time complexity will depend on the implementation of select, feasible and add or union? Don't you agree? Yes, it will depend on this. So if these abstract procedures are individually orders of one, then only the time complexity will be order of n, is it not? That's very simple. हाँ, अगर मान लीजिए, for example, if I would have given, very interesting, please observe. Suppose, for example, if I say, if feasible, per iteration, if feasible can be done in order of log n time. Per step, if feasible is implemented in order of log n time, follow me. And others are in order of one, select is in order of one, union is order of one, but feasible can be done per iteration, per step in order of log n time, then certainly the time complexity of my algorithm would become very clear. Neha is saying order of n log n. As simple as that. इस तरीके से टाइम डिसाइड होगा. अगर मान लीजिए feasible is done in order of n time, तो ओवरऑल कॉम्प्लेक्सिटी आपकी हो जाएगी n square. So that is why the total time taken by problem solvable by greedy method will invariably depends on the abstract procedure implementation, like select, feasible and union. Will depend on select, feasible and union. Very correct. So I hope you now understood the total working principle and how the time complexity is decided in problems of greedy method. Lastly, I would like to tell you that types of greedy problems. So that is also important. Come on, types of greedy problems. Let me see before I show you what are the types of greedy problems. Types of greedy problems. There are two types. Write down and tell what are the two types, please. Write down and tell what are the two types of greedy problems. Can abstract procedure become exponential? Why not, Satyam? It can become, definitely it can become. Why not? Let me see your study. कितना आप लोग पढ़े हो already? Types of greedy problem. There are two types. Come on. What are the two types? Yes. Subset paradigm. One is called subset paradigm and the other is called ordering paradigm. Ordering paradigm. Now first tell me what is subset paradigm and what is ordering paradigm. Anybody? Come on. Write down. Adir, Neha, Naveen Kumar. What is subset paradigm? Subset का मतलब क्या है और फिर ordering का मतलब क्या है? What does that mean? Subset के पहले subset के बारे में बताइए. What is subset paradigm of greedy approach? Come on, boys and girls. No, selection procedure based on some optimization measures. Okay, that is fine. But ultimately it will lead to what? It will lead to what? So subset paradigm, generally people say like you need to optimize something. That is true, but may not be true always. No possibility to find best or optimal solution. No, it is not like that. For every problem you have to find the best or optimal. If optimality is there, you have to determine the best and optimal. ठीक है, example you are saying knapsack, correct? Breaking a set into smaller pieces. No, it is not like that. It is not called a subset paradigm. आप एग्जाम्पल जो दे रहे हो मैं मानता हूं, दैट इज knapsack. There is another problem called job sequencing with deadlines. These are examples of problem that belong to subset paradigm. लेकिन क्या होता है इसमें? Minimum cost spanning tree is not subset paradigm. Yes, Mohammad Asif, you are right. This corresponds to selection of a subset. This corresponds to selection of a subset of given inputs. You don't have to select all. Selecting a given set of choices, subset. जैसा कि अगर आपको पता हो knapsack में, out of all given n objects you need to select a subset of them. Out of all given jobs you need to select a subset of them. Right? Select a subset. Subset paradigm. Out of all given vertices, I have to select those vertices that connect source to destination. Subset paradigm. You don't have to select all vertices. Subset. The other is ordering paradigm. आपको क्या है, inputs, पूरे inputs को आप एक particular order में arrange करना है. एक particular order में arrange करना है. That is ordering paradigm. अब यहाँ पे आप बताइए मुझे, give an example. Let me see who will answer. Give an example of a greedy method or greedy problem which belongs to this category of ordering paradigm. Ordering paradigm. Let me see. Come on. Give a couple of examples or one example at least that belongs to ordering paradigm of greedy approach. So Kruskal's algorithm belong to which problem? Zoheb Hassan, job sequencing with deadline is not subset, is not ordering paradigm, is subset paradigm. Job sequencing with deadlines. Knapsack problem is subset paradigm, please. यहाँ पे लिखा हम already we have written. Yes, I am talking about ordering paradigm. Ordering paradigm, somebody has said minimum cost spanning tree. और एक भी एक important, somebody has already written earlier, I am writing it, optimal merge pattern. यहां पर कोई एलिमिनेशन की बात नहीं होती है. यू हैव टू रीऑर्डर द एलिमेंट्स, राइट? स्पैनिंग ट्री, ऑप्टिमल मर्ज पैटर्न, या आप टेप स्टोरेज प्रॉब्लम, टेप स्टोरेज, ऑप्टिमल टेप स्टोरेज विषय, शॉर्टेस्ट पाथ इज सबसेट बिकॉज यू डोंट हैव टू सेलेक्ट ऑल वर्टिसेस. लेकिन आप मिनिमम कॉस्ट स्पैनिंग ट्री में और स्पैनिंग ट्री में आपको पूरे वर्टिसेस सेलेक्ट करने होंगे, राइट? सो दैट इज द डिफरेंस बिटवीन सबसेट एंड ऑर्डरिंग पैराडाइम. उसका डेफिनेशन मेरे नेक्स्ट स्लाइड में है, आप देख सकते हो. प्लीज हैव अ लुक, एक बार पढ़ लीजिए ये. प्लीज हैव अ लुक एट इट. The point is to solve a problem or possibly find the optimal or best solution. Greedy approach generates subset by selecting one or more available choices. Generate a subset. जैसे कि knapsack में आप एक subset generate करोगे, job sequencing में deadline में subset generate करोगे, right? Subset of items or subset of jobs, right? Ordering paradigm में, in this greedy approach generates some arrangement or order to get the best solution. You generate, like in minimum cost spanning tree, you may say you are arranging the vertices, right? All the selection of vertices in some order. That is ordering. That is ordering. Or best, another best example, जैसा पिछले slide में मैं दिया था, optimal merge patterns. Means you are given a set of files. You are given a set of files. how should you merge the files such that the total number of record movements is minimum? It's the optimization problem with a ordering paradigm. किस ऑर्डर में आपको फाइल्स मर्ज करना है so that the number of record movements are minimum? That is a problem. So that is a ordering paradigm. So any problem which you are solving using greedy method has to be basically either decision or optimization. Secondly, it has to be in the category of either subset paradigm or ordering paradigm. ये आपको अंडरस्टैंड करना है. शायद ये बेसिस पर भी सिंपल कभी कोई क्वेश्चन आ सकता है जिसमें चॉइसेस में आप मेंशन करोगे ये सबसेट पैराडाइम, दिस ऑर्डरिंग पैराडाइम, स्टेट ट्रू एंड फॉल्स टाइप के क्वेश्चन हो सकते हैं. तो बी क्लियर विद दिस टर्मिनोलॉजी. अब तक जितना भी हमने डिस्कस किया इट वाज ओनली ऑन टर्मिनोलॉजी, मेथोडोलॉजी एंड देन द इंपॉर्टेंट टर्म्स एंड कॉन्सेप्ट्स. अब ये बेसिस पर हम केस स्टडीज लेंगे. we'll take up the case studies now. Okay. The first case study that I'm taking for generally very interesting and simple problem, जिसके बेसिस पर प्रीवियस गेट क्वेश्चंस में, प्रीवियस गेट पेपर्स में क्वेश्चंस भी आए थे, राइट. द फर्स्ट केस स्टडी इज कॉल्ड नैपसैक प्रॉब्लम. और काफी टेक्स्ट बुक्स ऑफ ऑपरेटिंग सिस्टम में यही प्रॉब्लम से स्टार्ट की जाती है विद ग्रीडी अप्रोच, राइट, ग्रीडी मेथड, नैपसैक प्रॉब्लम. इट्स बेसिकली यहां पर लिख दूं मैं आपको, इट इज एन ऑप्टिमाइजेशन प्रॉब्लम plus it belongs to the category of subset paradigm. शायद आपको डेफिनेशन भी प्रॉब्लम का डेफिनेशन पता हो, फिर भी मैं फॉर्मेलिटी के लिए यहां पे कंप्लीट कर दूंगा, राइट. फिर हम अप्रोचेस ऑफ ग्रीडी देखेंगे, क्या क्या ग्रीडी अप्रोचेस हो सकते हैं और वो ग्रीडी अप्रोचेस में कौन सी स्ट्रैटेजी सबसे ऑप्टिमल और बेस्ट होगी वो भी हम देखेंगे, ठीक है. फिर उसके बाद देन वी विल टेक अप सम टिपिकल गेट क्वेश्चंस ऑन दिस, राइट. So that will be our methodology. The problem definition goes like this. We are given a knapsack. Knapsack का मतलब क्या है? एक बैग which has a capacity of m. Capacity का मतलब the amount of weight that it can hold or the volume of objects that it can hold. Generally weight लेंगे हम यहाँ पर, ठीक है. It has got some capacity of m. In addition to that, we are given some n objects. n objects. यहां पे कुछ इंटरेस्टिंग क्वेश्चन पूछूंगा, बी रेडी टू आंसर. n objects. ऑब्जेक्ट्स को हम डेजिग्नेट कर लेंगे i, oi, i going from 1 to n, i going from 1 to n, n objects. Each object is associated with its weight, जिसे हम लिखेंगे wi, and profit pi. These two things are given, weight and profit. और उन दोनों का रिलेशन ये है कि if I put a object of weight wi into the knapsack, the knapsack भर जाएगा weight wi से, right, and we get profit of pi. Again I repeat, if I put an object of weight wi into the knapsack, knapsack will get filled up by the weight wi and I will get naturally profit of pi. Profit of pi. That is the point. तो चूंकि यहां पर प्रॉब्लम में हमारे पास प्रॉफिट दिया गया है, प्रॉफिट पैरामीटर दिया गया है, सो नेचुरली एंड ऑब्वियसली व्हाट वी वुड लाइक टू डू, वी वुड लाइक टू मैक्सिमाइज द प्रॉफिट. तो जब आप बोलेंगे मैक्सिमाइज प्रॉफिट करने के लिए, तो यहां पर एक बात आएगी कि भाई देन यू पुट एवरीथिंग इनटू द नैपसैक. लेकिन आप ऐसा नहीं कर सकते हो, राइट. यू कैन नॉट डू इट. व्हाई? We have an explicit constraint here. I am writing, this is my first question to the class. Come on, boys and girls, be ready. First question. What should be the relation between, generally people make mistake here, between sigma wi, I is equal to 1 to n. What is wi? Weight of object I. Sigma wi, I is equal to 1 to n and the knapsack capacity m. For the problem to be solvable, मेरा question अच्छे तरीके से सुन लीजिए. For the problem to be solvable, अगर आप problem non-trivial way में solve करना चाह रहे हो, then what should be the relation between sigma wi and m? Come on. यहाँ पर generally people make mistakes, so I would like to see your level of preparation. What must be the relation between sigma wi and m? Very interesting. Satyam B Nayak. Less than or equal to, ऐसा लिख के बताइए. Less than or equal to या greater than or equal to, ये बताइए. Less than or equal to और greater than or equal to. जोएब हसन, प्रशांत प्रभाकर, sigma wi must be less than or equal to m or w greater than or equal to m. Come on, very interesting point. यहां पर अभी वही गलती कर रहे हो जो मैंने देखा है पहले पिछले क्लासेस में भी ऐसे ही. Satyam Binayak you are saying greater than or equal to. Neha is saying should be less than or equal to m. Prashant Prabhakar is also saying less than or equal to. Please understand. अगर if this is less than or equal to, please understand. अगर मान लीजिए if this is true, then now you realize what is the meaning. अब इसका मतलब सोचिए आप. अगर ये true हो, sigma wi is less than or equal to m. What is sigma wi? Sigma wi is total weight of all objects. Please, boys and girls, listen to me carefully. Sigma wi is sum of weights of all objects. If that is less than or equal to m, means that you can put everything into the knapsack. You can put everything into the knapsack and run away. Is it not? You can put everything into the knapsack. तो वहां पर आपको कोई डिसीजन मेक करने की जरूरत नहीं है. डोंट हैव टू मेक एनी डिसीजन. आपको कोई डिसीजन लेने की जरूरत ही नहीं है. कोई जरूरत नहीं है. यू पुट एवरीथिंग इनटू द knapsack and run away, and you can straight away say that the total profit for this will be sigma pi. Come on, tell me, can I get total profit as sigma pi or not? P1 plus P2 plus P3 plus P4 plus Pn. Are you getting my point, please? If sigma wi is less than or equal to m, then definitely I can say that my total profit is sigma pi. I don't have to solve the problem. मुझे कोई जरूरत नहीं है प्रॉब्लम सॉल्व करने की. मुझे कोई जरूरत नहीं है प्रॉब्लम सॉल्व करने की. सिग्मा pi is my answer. Where is that I am making the decision? हर ऑब्जेक्ट तो आप तो प्लेस कर चुके हैं knapsack में. You don't have to make. So this case, if this is true, I call this as from my side trivial case. Is trivial. Trivial का मतलब है unimportant. Problem need not be solved if this is true. Problem has to be solved. Please listen. Problem has to be solved only when sigma wi I equal to 1 to n is greater than m. Then only I have to solve. जब आप पूरे ऑब्जेक्ट्स मिला के आप अगर ऑब्जेक्ट्स आप knapsack में नहीं डाल सकते, right? You cannot put everything into the knapsack. Then only you have to make a decision. तभी मुझे डिसीजन लेना पड़ेगा. क्या डिसीजन लेना पड़ेगा? कि फर्स्ट ऑब्जेक्ट कितना डालूं, सेकंड ऑब्जेक्ट डालूं या ना डालूं, थर्ड ऑब्जेक्ट डालूं या ना डालूं, राइट, फोर्थ ऑब्जेक्ट अगर डालूं तो कितना डालूं. देन ओनली हैव टू मेक अ डिसीजन. आई होप यू आर अंडरस्टैंडिंग दिस पॉइंट. ये बहुत इंपॉर्टेंट है. ऐसे ही केसेस पर स्टूडेंट्स मिस्टेक करते हैं एग्जाम में. दैट इज व्हाट आई वांटेड टू ड्रॉ योर अटेंशन. बात तो समझ में आ गई? ठीक है. सो देयरफॉर सिग्मा wi शुड बी ग्रेटर देन m. देन ओनली हैव टू मेक अ डिसीजन. देन ओनली हैव टू मेक अ डिसीजन. सो जब हम डिसीजन की बात करें तो यहां पर हम लिख लेंगे द डिसीजन दैट वी आर मेकिंग एन ऑब्जेक्ट. डिसीजन दैट वी आर मेकिंग इन द ऑब्जेक्ट, लेट अस इंडिकेट बाय पैरामीटर xi. So this we have to work for. This we have to work for. This we have to work. This will be given to us. So based on the wi and pi, we have to decide what should be xi. Xi is my decision on object I. What is the decision? How much should I place? Or should I place or not place? This is the decision. So based on this, we classify knapsack problem into two types. So based on this decision making, I say that knapsack problem is classified based on what? Based on this decision making of xi. Based on this decision making of xi, there are two types or two versions of knapsack problem. बताइए क्या है? एक है रियल और फ्रैक्शनल knapsack, रियल और फ्रैक्शनल knapsack, और दूसरा है 0-1, जिसे मैं अपनी वर्ड में बोलूंगा बाइनरी knapsack. रियल और फ्रैक्शनल knapsack में जैसा वर्ड बता रहा है रियल और फ्रैक्शनल, यू कैन टेक फ्रैक्शन ऑफ द ऑब्जेक्ट. दैट मीन्स xi कैन लाई बिटवीन 0 and 1. xi कैन लाई बिटवीन 0 and 1. एनी रियल वैल्यू, एनी फ्रैक्शनल वैल्यू. मतलब आप हाफ ले सकते हो ऑब्जेक्ट की क्वांटिटी, या 1/4 ले सकते हो, या 1/10 ले सकते हो, या एनी फ्रैक्शन लाइंग बिटवीन 0 and 1 आप ले सकते हो ऑफ ऑब्जेक्ट आई. ऑब्जेक्ट इज ब्रेकेबल, यू कैन टेक द फ्रैक्शन. उसका ऑपोजिट है 0-1. 0-1 का मतलब है आइदर यू प्लेस द ऑब्जेक्ट और यू डोंट प्लेस इट. यू डोंट प्लेस इट. यू कैनॉट ब्रेक द ऑब्जेक्ट, यू कैनॉट टेक द फ्रैक्शन ऑफ द ऑब्जेक्ट. वो मतलब है बाइनरी का. जनरली बाइनरी knapsack प्रॉब्लम कैनॉट बी सॉल्व यूजिंग ग्रीडी मेथड. Cannot solve. We'll see an example for that, right? And fractional knapsack. So this is solvable by greedy. The fractional knapsack is solvable by greedy method. So we'll work out this fractional knapsack. Dynamic programming DP, you can solve. You can get a correct solution for binary knapsack using dynamic programming. So that is another point you should remember. 0-1 knapsack problem is not solvable by greedy method, whereas fractional knapsack is always solvable by greedy method. तो जनरली एक एग्जाम्पल यूजुअली देता हूं मैं स्टूडेंट्स को टू अंडरस्टैंड द डिस्टिंक्शन बिटवीन फ्रैक्शनल नैपसैक एंड बाइनरी नैपसैक. वो एग्जाम्पल ये है, देयर आर मेनी रियल लाइफ एग्जाम्पल, देयर आर मेनी रियल लाइफ इंस्टेंसेस वेयर वी यूज दिस कॉन्सेप्ट ऑफ नैपसैक प्रॉब्लम. जैसा कि मैं कहता हूं अपने वर्ड में, अपने ओन वर्ड्स में, ओन एग्जाम्पल में, कि जो सूटकेस पैकिंग प्रॉब्लम जो होता है, राइट, दैट इज ए नैपसैक प्रॉब्लम. आप एक फ्लाइट ले रहे हो, राइट, यू वांट टू गो अब्रॉड और समवेयर, यू हैव basically booked a flight. Generally the flight will put a restriction on your baggage. बोलेंगे कि sir, you cannot carry more than 25 kgs, 30 kgs. And let's say you are going to US or UK for pursuing higher studies. तो जब आपका वीजा आ गया, आप एंडोर्समेंट करा लिए, टिकट बुक कर लिए, then basically you basically have the restriction on your baggage. Then you tell your mom, I want to carry some items, so I have to package, I have to make the package of my baggage. So what are the possible items that you would like to take to go abroad? Maybe like clothes, food items, particularly Indian subcontinent से जो generally student जाते हैं, the most often they prefer to carry pickles, achar, papad, etc. Right? So you told your mom, please make some achar for me, make some pickles for me, I want to carry. He prepared 3 kgs of pickle. Oh, you say it's not possible for me to carry 3 kgs. You say that I will take only half of it, 1.5 kg. They are taking fraction. So total weight of the object is 3 kg and you are taking only half of it, right? 1.5 kg or whatever. That is an example of fractional knapsack. अब मान लीजिए for example binary का एक example ले सकते हैं आप. क्या you want to make a decision on your laptop? Should I carry my laptop or not? So that has to be binary. Certainly you cannot say that I will carry the top one and leave the bottom one here, right? Top portion of the laptop I will take and bottom portion I will leave it here. That's not possible. So either you have to take it or you have to drop it. That's it. That is binary. So that's a case of the problem. So there are many examples which can be taken to understand the ideology of knapsack problem. तो हम इसे कैसे, generally the word knapsack जो word use होता है ना, that is used in defense arena, or you can say basically like what do you say, army people when they go for battlefield na, you might have seen army people, right, defense people who carry bags at their back. That bag is called knapsack. Yeah, it's a very to be at a lighter side, that example of laptop, right? You cannot break the laptop and take I say that I will take half of it and leave the remaining half. It's not. Either you have to take it fully or drop it. That's the point. तो जो आर्मी सोल्जर्स, जो आर्मी के जो सोल्जर्स होते हैं, जो बैग पीछे लेके अपने बैटलफील्ड में जो जाते हैं वो लोग, that bag is actually called knapsack. So before proceeding to battlefield, they have to go to what is called army repository. Repository मतलब स्टोर हाउस. तो वहां पे उनको अपने कुछ आइटम्स फिलअप करना होगा बैग में, लाइक फूड आइटम्स हो सकते हैं या फिर एमुनेशन हो सकता है, विच विल बी यूजफुल फॉर इट. सो दैट इज कॉल्ड knapsack प्रॉब्लम, और वही वहां से शुरू हुआ. So means they have to fill up with those objects which will be useful for them in the battlefield or useful for them in the project which they have been assigned to, right? Maybe like guarding the post or whatever you say, that is called knapsack. Or those who go for skiing or maybe adventure trips, they also carry the bag, that is also called knapsack problem. So there are innumerable cases of knapsack problem. तो चलिए ये होगा greedy knapsack. अब हम mathematical problem डेफिनेशन दे देंगे, यहाँ पे प्रॉब्लम डेफिनेशन बना देंगे मैथमेटिकली ऑफ नैपसैक प्रॉब्लम. ठीक है, द मैथमेटिकल डेफिनेशन गोज लाइक दिस. तो मैं फिर से एक बार लिख रहा हूं यहाँ पर. ऑन ऑब्जेक्ट आई यू हैव टू मेक ए डिसीजन. डिसीजन इज गिवन बाय एक्स आई एंड एक्स आई लाई बिटवीन 0 and 1. हमने पहले ही कहा, राइट. द वेट ऑफ ऑब्जेक्ट आई इज डब्ल्यू आई एंड द वेट ऑफ एंड द प्रॉफिट इज पी आई. सो विथ रेस्पेक्ट टू द डिसीजन, the corresponding weight that goes into the knapsack will be WIXI. Am I right? I hope you'll follow it. With respect to the decision on object I, the weight that goes into the knapsack now will be written as function WIXI, और उसका जो associated profit आपको मिलेगा वो हम लिखेंगे mathematically PIXI. P1X1 means the profit with respect to object 1. P2X2 profit with respect to object 2. Decision made on object 2. उसी तरह like that. So based on this we say we would like to maximize मैक्सिमाइज व्हाट? द टोटल प्रॉफिट. टोटल प्रॉफिट क्या होगा? सिग्मा पी आई एक्स आई, आई गोइंग फ्रॉम 1 to n. ये आपको मैक्सिमाइज करना है, ये प्रॉफिट आपको मैक्सिमाइज करना है, राइट? मैक्सिमाइज द प्रॉफिट subject to what condition? Subject to the condition that the total weight that goes into the knapsack should not exceed the capacity. मतलब sigma wi xi, this is the total weight going into the knapsack 1 to n. This should be less than or equal to m. Please don't get confused. हमने कहा पिछले बार sigma wi should be greater than m. देखिए आप, sigma wi should be less than or equal to m first. Sigma wi should be greater than m. लेकिन sigma wi xi should be less than or equal to m. Sigma wi xi ये कह रहा है कि the total weight that you put into the knapsack, that should be less than or equal to m. Where we say xi, where xi lie between 0 and 1. This is called the formal definition of knapsack problem, greedy knapsack. Greedy knapsack. अब यहां पर मैं आपको बता रहा हूं in terms of terminology, maximizing this is called objective function. This is called objective function. Satisfying this constraint is called implicit constraint. Implicit constraint, या फिर आप इसे ये भी बोल सकते हैं like feasibility criteria. It is also called feasibility criteria. It is also called feasibility criteria. अब मुझे टर्मिनोलॉजी के हिसाब से कोई बताएगा what is this known as in terms of our terminology that we have defined. Problem definition हमने देखा, right? Yes, Satyam Binayak, ideally that should be equal to m, as you are saying, correct. Neha Mishra, again I am telling you, please follow. Check here. Sigma wi, एक बार आपके convenience के मैं लिख रहा हूं. This is sum of weights of all objects. जितने भी जो आपके ऑब्जेक्ट्स दिए गए हैं ना, दैट इज द सम ऑफ ऑल, उनका टोटल वेट है सिग्मा wi. नेहा मिश्रा, प्लीज गेट कंफ्यूज, डोंट गेट कंफ्यूज. सिग्मा wi इज द टोटल वेट ऑफ ऑल ऑब्जेक्ट्स. ऑब्जेक्ट 1, ऑब्जेक्ट 2, ऑब्जेक्ट 3 सबका मिला के कितना वेट है? तो दैट हैज टू बी ग्रेटर देन m. इट कैन नॉट बी लेस देन m. क्यों? क्योंकि आप पूरे ऑब्जेक्ट्स फिल नहीं कर सकते नैपसैक में. जैसा कि आप वॉट एवर यू वांट, यू कैन नॉट टेक इट इन योर बैग. आई होप यू आर अंडरस्टैंडिंग. लेकिन सिग्मा wi xi इज द वेट दैट यू आर पुटिंग इनटू द नैपसैक. प्लीज ऑब्जर्व, एक कमेंट लिख दूंगा आपके अंडरस्टैंडिंग के लिए. दिस इज नथिंग बट वेट बीइंग पुट इनटू द नैपसैक. समझ में आ गई बात? दिस अ वेट दैट इज बीइंग पुट इनटू द नैपसैक. जो आप वेट नैपसैक में डाल रहे हो वो वेट है ये. This cannot be greater than m. This has to be less than or equal to m. You cannot put something beyond the capacity of knapsack. I hope you are following. Am I clear? Am I clear? ठीक है. अब ये बोलिए आप, where 0 less than xi, in terms of terminology, what do you call this condition as? Come on. What do you call this condition? If this is called objective function, if this is the feasibility criteria, then 0 less than or equal to xi is less than or equal to what? This is called explicit constraint. This is called explicit constraint because anything that limits the values, like xi cannot take value beyond 0 and 1, that is called explicit constraint. So this is called knapsack problem. और एक भी एक 1 mark question यहाँ पर पूछ रहा हूँ, very interesting. Come on. Interestingly I'm asking the question. Question 1. What is the solution space of real or fractional knapsack? Come on. And question 2, what is the solution space of 0-1 knapsack? 1 mark question each. Come on, boys and girls, work out and tell. This is how you can find the solution space for every problem. as a matter of fact, हर problem का इस तरीके से आप solution space निकाल सकते हो, determine कर सकते हो. और मैं बार बार कह रहा हूं कि एक 1 mark question हो सकता है. What is the size of solution space of real knapsack and what is the size of solution space of binary knapsack? बहुत simple है. Let me see who will answer. Come on, let me see who will answer this question. What is the size of solution space of real knapsack and what is the size of solution space of binary knapsack? Very correct, Adir. For binary knapsack, solution space will be order of 2 power n. Why? Very simple. See, I have to make n decisions x1, x2, so on, xn. मुझे इतने decisions make करने हैं x1, x2, so on, xn. In the case of 01 knapsack, boys and girls, please have a look. In the case of 01k knapsack, each xi can take two values, either 0 or 1. Each xi can take two values, 0 or 1. So I have n Boolean variables. I have n Boolean variables. So how many combinations can I have? I can have 2 power n. So therefore, the size of solution space of of binary knapsack is 2 power n. The size of solution space of binary knapsack is 2 power n. Very correct. But what is the size of solution space of fractional knapsack? What is the size of solution space of fractional knapsack? Come on. You can make a simple observation and tell the answer. I need to make n decisions. ये जो decisions है, ये decisions के basis पर आप size of solution space determine कर सकते हो. Size of solution space. क्योंकि solution space क्या है? All possible ways of organizing the inputs. So earlier we said each xi. Earlier हमने कहा each xi can take two values, 0 or 1. Now each xi can take how many values? Come on. Each xi. In the case of fractional knapsack or real knapsack, each xi lying between 0 and 1 can take how many values? Between 0, like for example, if I write 0 less than or equal to x1 less than or equal to 1, कितने real values होंगे x1 के? Right? There will be infinite values. Infinite. Infinite ऐसे नहीं लिखेंगे. We'll write infinity like this. So therefore each xi can take infinite values. So therefore the size of solution space is also infinite. Is also infinite. So real knapsack is one problem whose solution space is infinite. Is infinite. तो चलिए आगे बढ़ेंगे. आगे बढ़कर problem solving strategy देखेंगे knapsack की. Right? Real knapsack और fractional knapsack. एक instance ले लेंगे. Let us say we are given 3 objects. Knapsack capacity is something like this 20. Right? The profits P1, P2, P3. The profit vector 24, 15. The weights of the objects W1, W2, W3 is equal to 18, 15, 10. This is my data. So if you observe this data, very clear that sigma Wi is greater than 20. 18 plus 15 plus 10 is definitely greater than 20. इसका मतलब ये है कि you cannot put all the 3 objects into the knapsack. So I have to make a decision. मतलब मुझे decide करना है what will be x1, what will be x2, what will be x3. So my first question to the class is, when I am solving this problem based on greedy approach, when I am solving this problem based on greedy method, then question is, what can be that I can be greedy about? Come on. Greedy about what? What can be I greedy about? बोलिए. Yeah, Shifu Qadir, as I told you, local optimality does not generate optimal solution always. Reason we will see when we start dynamic programming. Right, greedy about naturally profit. Greedy about profit. Greedy about profit. That means we will try to include that object first which will have highest profit, maximum profit. अब देखिए आप, ये जो objects है इसमें highest profit है 25. So therefore, if I follow greedy about profit strategy, x1 will be 1. First object you would place into the knapsack. Knapsack capacity है 20. First object का weight है 18. So knapsack get filled up by 18. Balance capacity कितनी रह गई knapsack में? 2 रह गई. Second, next highest profit object कौन सा है? 24 है. Second object. लेकिन आप पूरा ऑब्जेक्ट नहीं ले सकते क्योंकि उसका टोटल वेट है 15 यूनिट्स और हमें चाहिए सिर्फ 2 यूनिट्स. क्यों? क्योंकि knapsack में जो बैलेंस कैपेसिटी लेफ्ट ओवर है सिर्फ 2 kg है. राइट? सो देयरफॉर आई हैव टू टेक ओनली 2 ऑफ 15, 2 by 15. थर्ड ऑब्जेक्ट के लिए कोई कैपेसिटी बाकी नहीं है तो थर्ड ऑब्जेक्ट का डिसीजन होगा 0. So with respect to these decisions, definitely I can say that sigma Wixi is 20. Knapsack is fully filled up. अब ये डिसीजन के बेसिस पर आप प्रॉफिट बताएंगे सिग्मा पी आई एक्स आई क्या होगा. फर्स्ट ऑब्जेक्ट इज फुल्ली प्लेस्ड, तो मतलब 25 प्लस सेकेंड ऑब्जेक्ट आप 2/15 फ्रैक्शन ले रहे हो, सो 2/15 ऑफ 24. थर्ड ऑब्जेक्ट का आप इंक्लूड ही नहीं कर रहे हो, 0. तो दिस वैल्यू इज रफली हाउ मच, प्लीज टेल मी. 2/15 of 24 is how much? Use calculator and tell. I'm not having calculator here. 28.2. Very good. So therefore this is 28.2. लेकिन क्वेश्चन ये है कि is this, listen, is this the optimal strategy? क्या ये optimal strategy है? Is this an optimal strategy? This may not be optimal strategy. क्यों? क्यों? Can anybody tell me why is this not an optimal strategy? Can anybody tell me why is this not optimal? ठीक है, I mean I agree with you. You are saying no, it is not optimal. क्यों? Reason क्या है? That is important. Why is this not optimal strategy? Tell me, Neha Mishra, Kapil Agarwal, you are saying no very correctly, Rahatullah. But why is this not optimal? Why is this not optimal? That is also important to understand. Why is this not optimal? I'm saying greedy about profit, but you are saying it is not going to be optimal. Why? Can anybody tell me the reason? Let me see. Because we can make more profit. ठीक है, वो तो बता सकते हैं, लेकिन why this is not going to generate more profit? Why this is not going to generate more profit? That is my question. When I say greedy about profit, why? Yeah, you have to take ratio. All that is okay, correct. लेकिन ये जो हमने अभी अप्लाई किया है स्ट्रैटेजी के we'll select the object with highest profit first. Why is that not optimal? Is my question. Yes. Because Satyam Binayak has told correctly. Look at his answers. Object with highest profit may have high weight. मतलब ये है, strictly speaking, boys and girls, please follow me what I am saying. Strictly speaking, I cannot say this is highest profit. Strictly speaking, I cannot say that this is highest profit. क्यों? क्योंकि weights different है 18, 15, 10. हाँ, अगर हर ऑब्जेक्ट का वेट होता 18, 18, 18, तो जब हम कहते हैं कि 25 इज हाईएस्ट प्रॉफिट, डेफिनेटली. जब वेट्स यूनिफॉर्म ना हो, 18, 15, 10, दे आर नॉट यूनिफॉर्म, देन फ्रैंकली और स्ट्रिक्टली स्पीकिंग आई कैन नॉट से फर्स्ट ऑब्जेक्ट इज ऑफ हाईएस्ट प्रॉफिट. और सेकेंड रीजन ये है, देखिए आप, इट इज 18 यूनिट, सडनली द knapsack गॉट फिल्ड अप बाय 18. So therefore, based on that, some other thought, there can be another school of thought here, another school of thought. Some people would say, sir, knapsack तो बहुत जल्दी भर जा रहा है. So maybe some school of thought can go like this. They will think that, sir, we can get more profit maybe by adding more and more number of objects. अगर हम ज्यादा objects add करेंगे knapsack में तो शायद हमें profit ज्यादा मिलेगा. So that is another possibility. हम वो कहते हैं strategy को greedy about weight. ग्रीडी अबाउट वेट का मतलब यह है कि हम वेट जो knapsack में डालेंगे वो ग्रेजुअली फिल करेंगे, स्लोली फिल करेंगे, सो दैट आई कैन अकोमोडेट मोर ऑब्जेक्ट्स, थिंकिंग दैट आई मे गेट मोर प्रॉफिट. अगर हम मान लीजिए ये स्ट्रैटेजी से सॉल्व करेंगे प्रॉब्लम को, तो क्या आप बताएंगे कि व्हाट विल बी x1, x2, x3? ग्रीडी अबाउट वेट का मतलब वी विल ट्राई टू इंक्लूड दैट ऑब्जेक्ट फर्स्ट विच इज हैविंग लीस्ट वेट, दैट ऑब्जेक्ट फर्स्ट विच इज हैविंग लीस्ट वेट. तो मतलब है x3 should be 1. इसका वेट है 10. बैलेंस कैपेसिटी knapsack में भी 10 है बिकॉज टोटल कैपेसिटी 20. नेक्स्ट लीस्ट वेट ऑब्जेक्ट है ऑब्जेक्ट 2, तो उसका वेट है 15, हमें चाहिए 10, सो फ्रैक्शन हमारा होगा 10/15, राइट. फर्स्ट ऑब्जेक्ट के लिए कोई रूम कैपेसिटी नहीं है, सो देयरफॉर बेस्ड ऑन दिस आई से अगेन सिग्मा WI XI इज 20. लेकिन प्रॉफिट कितना होगा सिग्मा PI विद दिस स्ट्रैटेजी? कितना होगा देखिए, आप कैलकुलेट कर लीजिए. थर्ड ऑब्जेक्ट इज फुल्ली प्लेस्ड, सेकेंड ऑब्जेक्ट इज 2/3 ऑफ 24, फर्स्ट ऑब्जेक्ट का प्रॉफिट 0 है, तो दिस इज 31. इट इज मोर देन प्रीवियस, लेकिन दिस स्ट्रैटेजी इज ऑल्सो नॉट ऑप्टिमल. व्हाई? बिकॉज व्हेन आई एम कंसिडरिंग वेट, आई एम नॉट गिविंग एनी वेट टू प्रॉफिट. When I am considering profit, I am not considering weight. So that is the reason these two strategies are suboptimal. I am not saying incorrect, suboptimal. They are giving profit, but suboptimal. So that means we need a strategy which is going to give weightage to both profit and weight. Giving weightage to both profit and weight. मतलब ये है, I want that strategy which is going to make the weights uniform. और हम जब उस पर जब देखेंगे कि कौन सा ऑब्जेक्ट ज्यादा प्रॉफिट दे रहा है. The question is how to make the weights uniform. Anybody? How to make the weights uniform? Right now the weights are not uniform here. So question is how to make the weights uniform. Anybody? What should be done? What should be done? How to make the weights uniform? One way of doing that is, look at this. By putting weight of Wi into the knapsack, I am getting profit of Pi. By putting weight Wi into the knapsack, I get profit of Pi. अगर हम 1 kg अगर लेंगे ये ऑब्जेक्ट का वेट, तो कितना प्रॉफिट मिलेगा? हमें प्रॉफिट मिलेगा Pi by Wi. This is called profit per unit weight. मतलब हर ऑब्जेक्ट का एक एक यूनिट वेट लेंगे और प्रॉफिट कितना मिलेगा देखेंगे. फिर उसके बाद हम स्ट्रैटेजी अप्लाई करेंगे, विच वी विल कॉल इट एज ग्रीडी अबाउट प्रॉफिट बाय वेट. मतलब we are going to arrange the objects in decreasing order of P by W, and then you sequentially consider the objects. First object which is having the highest P by W, then second object having the next highest P by W, third object, like that you go, right? Ratio. तो पहले हम यहाँ पे क्या करना पड़ेगा? We have to work out the ratios. What is P1 by W1? 25 by 18. What is P2 by W2? 24 by 15. Then what is P3 by W3? 15 by 10. This is 1.5. What about 24 by 15? How much? What is 24 by 15? Come on. What is 24 by 15? I think that is 1.6. And this is like 1.3 something. Yes. 1.6 and 1.3. So that means if I take 1 kg of first object, I get profit of 1.3. If I take 1 kg of weight of second object, I get profit of 1.6. Third object will give me profit of 1.5. Achha, this is 1.4. Let us put 1.38 aata kuch. So 1.4 will put, no problem. Now based on this, we will try to include first which object? X2. First of X2. The X2 will be 1. What is the weight of second object? Weight of second object is 15. Leftover capacity in knapsack 5. Next highest profit weight object is third, so X3. इसका total weight है 10. हमें चाहिए 5, so 5 by 10 ratio. First object no room, so this is 0, right? So based on this again, we see sigma WIXI for this strategy is 20. लेकिन इसका profit कितना होगा? Sigma PIXI प्रॉफिट कितना होगा? इसका प्रॉफिट होगा सेकेंड ऑब्जेक्ट फुल्ली प्लेस, सो देयरफॉर 24. थर्ड ऑब्जेक्ट हाफ प्लेस, सो हाफ ऑफ 15. थर्ड फर्स्ट ऑब्जेक्ट इज 0, so this is 31.5. So that is why among all the three strategies, 28.2, 31 and 31.5, this is the ideal or correct greedy strategy for solving the problem. So ये basis पर मैं आपको ये कहना चाह रहा हूँ कि a problem may have multiple greedy strategies, लेकिन all of them need not be optimal. Like greedy about profit alone is not optimal. Greedy about weight alone is not optimal. Greedy about profit by weight is optimal. तो उसी तरह among all possible approaches of solving a problem, you have to greedily select that strategy which is optimal. Which is optimal greedy strategy. That is the correct way of solving it. अगर आप इसको implement करोगे algorithm में, assuming that you are already, the data is already sorted, then इसकी time complexity होगी order of n. If you see the algorithm, because I have to take a simple for I is equal to 1 to an n loop, keep on adding the objects until a particular object is not fully accommodatable. Then take a fraction of that object and leave it. That's it. That's the strategy. So that's why the time complexity of this is order of n. There were questions asked in earlier papers based on this approach. एक क्वेश्चन मैं लूंगा from previous paper. पहले आप सॉल्व करोगे, फिर उसके बाद हम डिस्कस करेंगे. चलिए, let us take a question on this from previous paper of GATE. Please have a look at it. Have a look at it. Come on. I'll give you a couple of minutes of time. Work out this problem. It is exactly based on knapsack. थोड़ा चेंज किए हैं in the GATE paper. So be careful with regard to the change that they are doing here in the problem. Read it thoroughly, comprehend it properly, understand, comprehend properly, and then you give me the answer. the value of V op minus V greedy is dash. So you have to tell the value. That is minus V opt minus V greedy is how much? Any answers? Come on, assume that you are solving in the exam and that way you should solve within time constraint. ज़्यादा ना कम और केयरफुली कीजिए कैलकुलेशंस. अगर आप पहली बार देख रहे हो क्वेश्चन तो अच्छे तरीके से समझिए क्वेश्चन एंड देन यू कॉम्प्रिहेंड इट प्रॉपरली एंड देन यू गिव मी द आंसर. Nobody so far? (18). Logical learner is saying 18. Neha is also saying 18. Come on, other people also. At least some answers have come. I would like to see from other people. Shifu Khadir is saying 13.5. Okay. I don't think you get a fractional value. Check it again. Neha, you can also check your answer again. Check your answer again, I'm saying. Avnish, okay. Shakia is saying 18. Okay. ठीक है. और भी कुछ देखेंगे आंसर. Many people are saying 18. Many people. I don't know. I also don't know, remember exactly the answer. I too have to work out. मैं भी work out करूँगा अभी. Then you can check whether your answer is right or wrong. But I'm sure 13.5 is not correct. 18 हो सकता है सही हो. लेकिन other people also. Come on, Satyam. What happened? Satyam B. Naik. Any contribution from your side? Okay. ठीक है, अब चलिए स्टार्ट करें. सत्यम बी नायक is saying 16. First time a different answer, 16. Satyam Naik is saying 16. So let us see what is the correct answer here. Okay. देखेंगे 16 सही है या मेजॉरिटी ने कहा 18, तो क्या 18 सही है या 16 सही है देखेंगे. तो प्लीज सी ऑन बोर्ड, इट्स इंटरेस्टिंग क्वेश्चन. कंसीडर द वेट्स एंड वैल्यू. वैल्यू का मतलब यहां पर इन रुपीज में है प्रॉफिट. ये वेट है WI. दिस इज पी आई, दीज आर आइटम्स, ऑब्जेक्ट्स, दिस ऑब्जेक्ट आई, ठीक है। द टास्क इज टू पिक ए सबसेट ऑफ दीज आइटम्स सच दैट देयर टोटल वेट इज नो मोर देन 11 kgs, मतलब नैपसैक कैपेसिटी है आपकी 11 kgs, टोटल वेट इज 11 kgs। ठीक है, नेहा मिश्रा विल कंपेयर व्हाट यू आर सेइंग इज राइट और रॉन्ग, ठीक है। मोर ओवर नो आइटम, हाँ दिस आई डोंट नो वेदर यू ऑब्जर्व दिस स्टेटमेंट और नॉट, ये बहुत इंपॉर्टेंट स्टेप है, इंपॉर्टेंट स्टेटमेंट दिया गया है यहां पर। मोर ओवर नो आइटम मे बी स्प्लिट, इसका मतलब ये है, इसका मतलब क्या है, इसका मतलब है कि आप आइटम को ब्रेक नहीं कर सकते, यू हैव टू टेक इट आइदर फुल्ली और ड्रॉप इट, दैट्स इट, यू कैनॉट ब्रेक इट। The total value of item picked up by an optimal algorithm is denoted by V opt. Some strategy कैसे होगा वो अलग बात है। Some optimal strategy अप्लाई कर हम तो टोटल प्रॉफिट गेन करेंगे, उसको हम बोलेंगे V opt। हाँ, यहां पर a greedy algorithm sorts the item by their value to weight ratios in descending order, जो हमने किया, and packs them greedily starting from the first item in the ordered list. Now the total value of item picked up by greedy algorithm is called V greedy. तो डिफरेंस क्या है V opt और V greedy में? बॉयज एंड गर्ल्स, यहां पर आपको एक बात ये रिमेंबर करना है, greedy strategy is being applied with profit by weight ratio, लेकिन कंडीशन ये है जो हमने पहले सॉल्व किया प्रॉब्लम और ये प्रॉब्लम में डिफरेंस ये है कि यू कैनॉट ब्रेक द ऑब्जेक्ट इवन दो वी आर अप्लाइंग greedy strategy. So don't think that this is zero on knapsack, right? Greedy approach by not splitting the object, that is the meaning. There's a meaning. तो सबसे पहले what is the optimal solution that we get, value that we get by applying optimal strategy? क्योंकि 4 आइटम से आप इमीडिएटली डिसाइड कर सकते हो। देखिए आप, हाईएस्ट प्रॉफिट जो है 60 है, ठीक है, और इसका वेट है 10। ये 10 यूनिट्स ऐड करने के बाद आप कोई भी दूसरा ऑब्जेक्ट नहीं डाल सकते, ना ही आप फ्रैक्शन ले सकते हो ऑप्टिमल के लिए, ना ही फ्रैक्शन, बिकॉज नो ऑब्जेक्ट कैन बी स्प्लिट, राइट। अगर आप 60 ना ले, ये तीनों डाल सकते हैं क्या? ये तीनों भी नहीं डाल सकते हैं आप, क्यों? 7 + 4 + 2 विल बिकम मोर देन 11। अगर आप ये दोनों ऑब्जेक्ट्स डालेंगे तो आपका प्रॉफिट होगा सिर्फ 48। अगर ये दोनों डालेंगे प्रॉफिट होगा सिर्फ 44, या फिर सेकेंड और फोर्थ डालेंगे तो आपका प्रॉफिट होगा 52। तो मतलब ये है, राइट, मतलब ये है कि आपका मैक्सिमम प्रॉफिट जो होगा वो सिर्फ 60 होगा, उससे बढ़ के आप प्रॉफिट हरगिज नहीं ला सकते। तो मतलब V opt की वैल्यू हो गई 60। ये तो क्लियर होगा? इज दिस क्लियर? ठीक है, अब हम ग्रीडी स्ट्रैटेजी पे आएंगे। V greedy के लिए कैलकुलेट करेंगे V greedy। इसके लिए हमने क्या कहा? एज पर द गिवन कंडीशन, फर्स्ट ऑफ ऑल वी हैव टू फाइंड P1 by W1, राइट, P2 by W2, देन P3 by W3, P4 by W4, क्योंकि प्रॉफिट बाय रेशियो ग्रीडी के लिए यही कंडीशन है, ठीक है। व्हाट इज P1 by W1? 60 by 10 6, 28 by 7 4, 20 by 4। देखिए गेट का कॉन्सेप्ट ये रहता है, बहुत सिंपल तरीके से डेटा देते हैं सो दैट यू हैव इनफ टाइम फॉर कंप्यूटेशन। दिस 5, दिस 12। अब मुझे बताइए, with this approach, which object will you include first into the knapsack? You will include that object first into the knapsack which is having highest profit by weight ratio. Highest profit ये है 6, ये है 4, ये है 5, ये है 12। तो मतलब ये है first object that will go into the knapsack with greedy approach is object 4, x4, it is equal to 1। समझ गए बात? is equal to 1। तो इसका वेट कितना है? इसका वेट सिर्फ 2 kgs है। तो अब तक प्रॉफिट कितना आ गया? यहां पर हम प्रॉफिट लिखते जाएंगे 24, फोर्थ ऑब्जेक्ट। इसके बाद विच इज द नेक्स्ट हाईएस्ट ऑब्जेक्ट दैट इज हैविंग हायर प्रॉफिट बाय वेट रेशियो? देखिए आप, 12 के बाद है नेक्स्ट 6, ये देख लिया आप 6, पर लेकिन इसका वेट कितना है? इसका वेट है 10। क्या हम ऐड कर सकते हैं? नैपसैक में 2 kg ऑलरेडी ऑक्युपाइड है, क्या आप 10 ऐड कर सकते हो? ऐड नहीं कर सकते। क्यों? यू कैन नॉट ब्रेक द ऑब्जेक्ट, यू कैन नॉट टेक द फ्रैक्शन ऑफ इट, वो कहा गया है यू कैन नॉट टेक इट, so therefore I cannot take this object। ठीक है, उसके बाद नेक्स्ट हाईएस्ट प्रॉफिट ऑब्जेक्ट वेट क्या है? थर्ड ऑब्जेक्ट 5। देखिए आप 12 हो गया, वी हैव इंक्लूडेड दिस, राइट, वी कैन नॉट इंक्लूड दिस, वी कैन वी इंक्लूड दिस थर्ड ऑब्जेक्ट? व्हाट इज द वेट ऑफ थर्ड ऑब्जेक्ट? 4। हाँ, वो इंक्लूड कर सकते हो, दैट यू कैन डेफिनेटली इंक्लूड, राइट। So because weight is 4 units, 4 plus 2 it becomes 6. So therefore I will put third object is also fully included. इसका profit कितना है 20. So 24 plus 20 हो गया. उसके बाद देखिए आप, so these two are included. Now the turn is only for second object. Second object का weight कितना है 7. Naturally you cannot even take fraction of it, क्योंकि question में दिया गया है. You cannot take the fraction. So therefore you have to discard this also. मतलब ये हुआ, तो x4 x3 is equal to 1, x2 is equal to 0, x1 is equal to 0 with greedy approach. तो आपका total profit होगा 44. So the value of V greedy is 44. तो difference कितना हो गया 44 to 60, 16 होगा ना. So therefore V opt minus V greedy is 16. So those who say 16, pat yourself, congrats yourself. If you have not done the problem earlier, now you have done, then definitely your approach is correct. तो इस तरीके से, यही मैं आपको बताना चाह रहा हूं कि इस तरीके से थोड़ा ट्विस्ट होगा प्रॉब्लम में. एज इट इज जैसा है वो नहीं आ सकता, थोड़ा ट्विस्ट होगा. आपको थोड़ा केयरफुली अप्लाई करना होगा प्रॉब्लम, एंड देन यू कैन गेट द आंसर. ठीक है, तो दैट इज. तो चलिए आज के लिए इतना ही. So next in the next session we will talk about the other problem, which is basically a graph based problem, single source shortest path Dijkstra's algorithm. उससे पहले मैं आपको जनरल एक शॉर्टेस्ट पाथ के बारे में जो वेरियस प्रॉब्लम्स है वो डिस्कस करेंगे. फिर Dijkstra's algorithm कैसे वर्क करता है वो देखेंगे. उसकी algorithmic टाइम कॉम्प्लेक्सिटी के बारे में बात करेंगे, और टाइम इफ परमिट्स वी विल आल्सो टेक अप some more problems. If even though we have not discussed, like we can take up some gate questions of traveling salesperson, job sequencing with deadline, or maybe you can even take up some questions on Huffman coding. ये भी काफी important problem है Huffman coding. उसके भी अगर कुछ problems है तो हम देख के problem solve करेंगे. So next class again we'll continue with greedy approach. Okay, take care and continue your rhythm of problem solving and gate preparation. Okay, thank you very much. Good night. Monday please, next class will be on Monday.